the left-hand side of the screen, which is about Benny cooking his tea. Now, Benny intelligently sees a boiling hot plate and decides he's going to lift that hot plate. Well done, Benny. The plate is too hot to hold, and Benny drops the plate. So the question's asking you, Benny's response to the hot plate is a reflex action. That's a reflex action. And immediately you should know, okay, a reflex action will not involve the brain at all. It's a reflex action. It's designed to protect you. It is designed, therefore, to be as quick as possible. Now, finish the flow chart below to show the path taken by the impulse that causes the reflex. Simple as this. You've got receptors in your arm. You've got receptors in your skin. You've got receptors that could be either pressure or could be heat. When those are activated, that's going to shoot a signal down your sensory neuron, because remember it's attached to a sense organ. And that sensory neuron will then be sent right down the arm, you can see here, over to his spinal cord, where it will meet relay neurons. Now notice there's no brain involvement here, because you're not sitting there going, I don't know. I don't know what to do with this boiling hot plate while my skin's blistering and I'm just about to squeal. No, should I drop this or should I not? No, you don't want that. It's a waste of time. You want to drop it as soon as possible, and therefore there's no brain involvement. It's all to do with the spinal cord. And so you don't think about it. It's automatic. That means that the relay neuron is located here, which then shoots the signal down your arm, through your motor neuron, and that will then activate an effector that's spelled E-F-F-E-C-T-O-R, not A. They won't give you a mark for that if you spelt that with an affector. That's not correct. So it's an effector, and the effector is usually a muscle or a gland. Now, if you think about it, that's going to activate the muscles in your fingers to contract, and therefore, or relax actually, and therefore let go of the plate and therefore drop it. So that is your reflex action. Remember, the key here is that there is no brain involvement and there is an effector involved, which will release the plate, dropping it. Okay, so here we go. Motor neurons are part of Benny's nervous system. Look at the diagram below of a motor neuron, write down the name of part X. Right, this part here, guys, is called your cell body, okay? This part here is called your axon, that middle bit there, and around your axon, to ensure that your nerves are transmitting the electrical impulse correctly, you've got something called myelin sheath. In fact, it's written here, myelin, just in case you need to know how to spell it. So there's your myelin, okay? So your myelin sheath insulates the electrical impulse and stops the electrical impulse from escaping. Now, of course, in conditions like MS, it is that myelin that breaks down, which is why the MS sufferer will either experience substantial amounts of pain or impulses that are involuntary. You've got, as I said, the cell body is located over here. You know it's a cell body because actually bang in the middle of that is a nucleus. So write down the name of part X. Part X is the cell body. Part C says, sometimes neurons can get damaged. Look at the pictures of an undamaged, there's your undamaged, and a damaged neuron, there's your damaged neuron. Now, remember what I just told you about the myelin sheath. You can see that the myelin sheath in this case is damaged, okay? There's a number of factors that could cause that. Mainly, it is an immune response. Your white blood cells may have attacked those particular areas, as is the case with MS, and as a result of that, that's why the sufferer, as I said, is rendered immobile or experiences a lot of pain. How could the damage affect the transmission of the impulses? So how could the damage, right? So your myelin sheath is damaged, okay? That's the explanation of your answer. Your myelin sheath is damaged here. And this could, how would the damage affect the transmission of impulses? Well, if it's damaged and its job is to transmit impulses quickly, well, if it's damaged, then it's going to transmit it very, very slowly. That's your 2 marks. So 1 mark comes from saying the word myelin sheath is missing or damaged, and the 2nd mark comes from the transmission will be slower. All right, so moving on. Question 7. Question 7 is to do with balancing equations. To do this without the ability of a whiteboard is an absolute nightmare. So listen, ladies and gents, I'm just going to tell you. Yeah, I'm just going to explain this question to you. Your teacher can do the explanations on the board to show you how to balance this correctly. And you'll see what I mean when I show you the answer. So this question is about fuel. Butane, which you can see is a hydrocarbon because it contains only hydrogen and carbon there, C4H10. You know it's an alkane because it ends in A-N-E. If it was an alkene, it would be ending in ENE. So it's not an alkene, it's an alkane. It burns in oxygen. It says here, carbon dioxide and water are made. Write a balanced symbol equation for this combustion reaction. Okay. C4H10 plus O2, arrow, which it means equals, as you know. Carbon dioxide is CO2 and water is H2O. Right. Now, if you just said that, that would give you 1 mark. You can see where my icon of it is over here. Formulae would give you 1 mark. The balancing of it is this bit here, and it means that you'd have to put a 6.5 there, a 4 there, and a 5 there. Now, your teacher, as I said, will explain this to you. I'm not going to waste any time going through that. Just know that that is the correct answer, and your teacher will explain to you how to get there. Okay, so remember, the principle here is everything before the arrow needs to be the same in number as everything after the arrow. Okay. Next question is to do with perfume. Question number 8. Helen has bought a new bottle of perfume. Draw a straight line to join each property of Helen's perfume, there's the property, to the most important reason. Right. So it is insoluble in water. Okay, why is it a benefit that it's an insoluble substance in water? So it doesn't wash off easily. So the line should have been drawn from there to there. It does not react with water. If it reacted with water and you put the bloody perfume on your skin, you're going to burn yourself. It's going to irritate the skin. Okay? And so you don't want that to happen. Okay? It does not react with water, so Helen can put the perfume directly onto her skin because obviously there's water being released through sweat on your skin. You don't want that to happen. Okay? And the fact that it's a non-irritant, okay? If it's a non-irritant, ladies and gentlemen, there we go. If it's a non-irritant, then that means that Helen can put the perfume directly onto her skin because you don't want any irritation being caused by the transmission of the substance onto the skin. Common sense, right? Right. B. Helen's friends are able to smell her perfume because it is volatile, meaning that it evaporates easily. Explain using ideas about particles why Helen's perfume evaporates easily. Right, very simple. Water or the perfume itself is gonna have, because it's a liquid, it will be having weak forms of attraction or weak I can't even speak anymore. Weak intermolecular forces between the water or the particles of perfume. When you can see it here, the particles will gain energy when they land on the skin. If you think about it, your skin is a little bit warm, that gives the particles energy, and the energy will will basically overcome those weak forces of attraction between water molecules or perfume molecules. And as a result of that, when it evaporates, you can smell it. Okay? I hope you enjoyed the smell sound that I just did there. So that is why you can smell perfume, because the heat from your skin will overcome the weak forces of attraction between molecules, and that is why the particles gain energy, and that's why the particles almost diffuse into your nostrils and you can smell it. Okay. All right. 9C. This is all to do with waves. This question, this is physics. I know it's your favourite topic in the world. So 9C. Mobile phones use microwave signals. Okay. There is not much diffraction of microwave signals around large buildings. Okay, there's not much diffraction, ladies and gentlemen, around large buildings, and this causes signal loss. One way a mobile phone company can reduce the problem is to boost the signal. Suggest 2 other ways a mobile phone company can reduce the problem of signal loss. Okay, so you've got a large building, it's interfering with your signal. Well, for 2 marks, one obvious thing to do is to ensure that you place the transmitter. If you imagine the transmitter is here and your building is here, well, your transmitter is going to whack against the building, isn't it? Your transmitter is going to whack the wave around on the building directly, and that's going to be a problem. So what's the solution to this? Put the transmitter higher. Put the transmitter higher, and that will allow for you to overcome the issue of an obstacle. It'll allow you to be in the line of sight to your receiver. Did you hear what I just said? It's the line of sight. So if you position it higher in the line of sight of the receiver, then, ladies and gentlemen, you've overcome the problem. Okay? All right, so that is 9C. Question number 10. This is a monster, all right? This is a monster. So I'll put the mark scheme on the right-hand side. This is designed solely to help you guys. So please do be using it. I mean, I'm talking through the answer here, but if you do feel the need to want to really pause the video and have a look at the intricacies of the mark scheme, please endeavour to do so. You are more than welcome to do that. That's why I put this on here for you. Right, question number 10. This question is about digital and analog signals. Look at the information showing what happens to the signals when noise is added to them. There's your digital signal, there's your analog signal. Right, so I'm breaking this question down for you the same way that I would have done so as a student. All right, so I hope that's useful. Now, let's look at the question. Oh, in fact, no, before we look at this question, let's analyze the diagram. All right, so digital signal over here, ladies and gentlemen, digital signal over here, it's only got one of 2 values. It's either on or off, or you could say it's 0, 1, 0, 1, 0, 1. You get the idea, right? When you add this thing called noise to it, you can see that it doesn't really change the shape of the digital signal that much. It just creates a little bit of a wobbly wave in certain places. And you can see it only affects the on value or the off value, right? It doesn't really tend to affect anything in the between here or between here. When you're looking at the analog signal over here on the right-hand side, you can see that this is the original wave. When you there's your noise signal, and when you add the noise signal to the wave, you can see this signal is messed up all the way through. All the way through that pattern, there is interference occurring in this wave, all the way through. Use the diagrams to explain why it's easier to remove noise from digital signals and how the properties of digital signals played a part in the switching from analog to digital TV broadcasts. There's 2 parts to this question. Use the diagrams to explain why it's easy to remove noise from digital signals. I'm going to do that one first, right? This is the first part. Use the diagrams to explain why it is easier to remove noise from digital signals. Right, watch. Okay. You've only got 0 and 1 values. Okay, you've only got 0 and 1 values. So it's easier to remove the noise from just one of 2 values than it would be to remove noise from a continuous value. Right? That's a continuous value. Whereas digital signals only have 2 values, 0 and 1, 0 and 1. You could say that was, I don't know, false, true, or you could have that as off, on, off, on. You get the idea. It's only got 2 values. Okay? Analog signals have a continuing value. So the interference is far more severe here than it would be for just 2 values. Okay? And you also look at it logically. the noise signal looks far more like the analog signal than it looks like the digital signal. So this is why the interference is felt so much with that, and also why it's much more difficult to remove the noise from the original signal, because actually the pattern is quite similar. Okay? As a result, guys, I mean, you get less interference with digital than you do with analog. There's a lot more interference with analog than there is with digital. Okay, so that answers the first part of the question. Okay, second part. How the properties of digital signals played a part in the switching from analog to digital. Can I just point out one thing? Where you've got this and, in your mind, you should put a slash across that, or even in the exam paper, put a slash across that, so it's very clear that that is the second part of the question. Then, when you see the and, you make sure that you put a slash across it so you understand the questions in two parts. My advice to you also, guys, is obviously underline your command words. You can see use the diagrams. That is definitely command, so use the diagrams. And the second one there is to explain why it's easier. That's the command word there, explain. And then the final one I would say here was how the properties, okay? That would be your, it's asking you a how. So that's your other command word. So this is what you need to be thinking of when you're looking at questions in an exam. What are the command words? What is the actual question asking you? And how many parts are there to the question? You can see there's basically two parts, one there, then after the word and, the second part there. And that's how you break down your 6-mark questions. You need to do it very, very, very logically based on what is in the question. Okay, so second part of the question, how the properties of digital signals played a part in the switching from analog to digital TV broadcasts. Okie dokie. Now, right. So the second part of the signal, let's have a look over here. Think about it. I mean, this is deeper knowledge than what is available really in this picture. Remember, digital signals can be multiplexed, right? Multiplexed. Now, I mean, I could open the book for you, but it's your job really to find out what multiplexing. It's your job to basically, what I was going to say, please look in your revision guide for a diagram for what multiplexing is. I mean, I suppose I could, in theory, do that here, couldn't I? What is multiplexing? What is multiplexing? Okay. So multiplexing. Okay. These are quite good diagrams, actually, guys. If I just show you. So if you've got a multiplex signal, you've got lots and lots and lots and lots and lots of chat, for example, lots of information, digital information that can go into a multiplexer. That is then jumbled up and sent down this shared channel here. And then at the end, you've got something called the demultiplexer, like a Sky TV box or a Virgin Media box. And that breaks it down into lots and lots of different channels. And what is the benefit of this, of course? Now think about it logically, right? What is the benefit of this system? You get lots more channels, and the channels tend to be a lot more clear and quality signals. You have more stations, that's what I've already said, more broadcasts, I've already said, wider range of programs, I've already said that. But it's important as well, you don't need a carrier signal for this. Now, if you don't know what a carrier signal is, a carrier signal, ladies and gentlemen, basically carries this wave along. That's what it does. It carries this wave along. That's what it does. Okay. Right. Happy? Well, I hope you are, because that was a meaty question. All right. So the final one for your core science exam is this little beauty here. Right. Okay. Lindsay and Kevin buy a new house. Their house. All right. Let's just look at the picture. All right. So this is what I do as a kid. I'd look at the picture, I'd see there's insulation in the loft, double glazed windows here, small double glazed windows, large windows on the south side of the house. Okay, so there's lots of opportunities here for the heat to actually be lost. Okay. Their house does not have cavity wall insulation, right? But is more energy efficient than most houses. Look at the picture. Explain how two energy saving features of their house improve its energy efficiency. So explain how right, it's got double glazed windows and it's got insulation and loft. There's your two. Use ideas about energy transfer in your answer. Now look at this logically. Double glazed, so where are we? There we are. Double glazed windows. If you've got double glazing in your windows, okay, let me show you. Oops, I don't want that. Double glazed. Okay, double glazed windows. Let's go to images. I don't know why I'm on Yahoo file. Okay. So if we look at these double glazed windows, right, okay. So if we look at the double glazing in there, you can see that there's one pane of glass, that's your single glaze. That is your second pane of glass, which is your double glazed window. And in the middle of that, you will either have one of two gas, either you will have no gas at all, in which case you've created a vacuum. Now, if you create a vacuum, ladies and gentlemen, you've taken out all the air particles, okay? If you've taken out all the air particles, no convection currents can form, and as a result of that, by the way, focus on that word convection current, no convection currents can form, and as a result of that, you end up with a very real situation that you won't lose heat, okay? So double glazed windows or small windows correctly linked to convection, right? Do you see that? Loft insulation, okay, loft insulation, if there's insulation in the loft, let me show you what loft insulation looks like. Huh? It would be useful if I could spell loft, that would be good, wouldn't it? Loft insulation, look at the state of the loft insulation. It is a sponge-like substance, usually fiberglass. And what loft insulation will do is it stops the formation, that's probably a better picture, it stops the formation of convection currents as well. It doesn't allow air to circulate and take heat out of the property. So if we're looking over here, use ideas about energy transfer in your answer. When we're talking about loft insulation correctly linked to convection or conduction, okay? I've linked it to convection mainly, ladies and gentlemen, which is largely the flow of current to take heat out of the property. As soon as the air current combines with the solid part of the roof, conduction would take it outside. And we don't want that to happen. So that's why insulation in the loft is there to prevent that from occurring. It also does say about the windows here. Windows allow passive solar heating by radiation. Radiation comes in from the sun, gets trapped in this glassy area here because it's designed that way to trap in heat in the walls and release it gradually. So that's dealing with three things there. We're dealing with convection, we're dealing with conduction, we're dealing with radiation in one answer. So any one of those would have given you 1 mark, but combined, two of those would obviously give you 2 marks. Okay. And I think that, ladies and gentlemen, is your mock exam done. So I hope that was useful. I hope you found that a useful tool, really. There'll be one for B2C2P2, B3C3P3, and B4C4P4 coming up. Okay, folks? So thank you very much indeed for your time. Best of luck revising. Speak to you later. Thank you.